Muscular System video lesson 4 in the series of 5. So we're getting there. We've made it through the two toughest to comprehend, the two largest video lessons. So we are on our way out here. A light at the end of the tunnel, hopefully. So if you've ever wondered when you sat down for Thanksgiving meal and someone asked you as they were serving you that glorious bird, and they asked you, do you want white or dark meat? If you ever wondered why turkeys have white and dark meat, you ever wondered why that was? Well, today's video lesson should answer that question for you. So let's not waste any time. Let's go ahead and get started. All right, everyone. Welcome to video lesson 4. All right, today we're going to talk about the different kinds of skeletal muscle fibers that can be found in your body. You may not have realized this, but there are 3 kinds of different skeletal muscle fibers you can have in your body. And in some instances, they will be in different concentrations for different muscles. And we'll talk about that here in today's video lecture. Skeletal muscle fibers are not all alike in appearance or function. First, let's talk about their appearance. Now, how do they look under a microscope? Now, before we get, or not even in a microscope in some instances, before we get too in depth in the kind that we can find in humans, I want you to think back here. Recently, we just got back from Thanksgiving break, and I'm sure a lot of us had that traditional bird as a meal. And most of the time, when someone asks you about the turkey you want, the typical question is, do you want white or dark meat? And the reason that they say that is because turkeys have, in different parts of their bodies, they have high concentration of either white or light meat muscle tissue. And that would be in the breast. A turkey breast is nice white meat, and that is the muscle that controls the wings. And the muscle in the drumstick, the legs, is dark. And the reason is going to be explained today. So red muscle fibers, so think about dark meat in a chicken or a turkey, have a high concentration of myoglobin, which is a substance your body will use for fuel to make ATP to move your muscles. They'll have a higher number of mitochondria, again, the powerhouse of the cell. They have more energy stores and have a greater blood supply. So not only do they have the material for prolonged use, the myoglobin, they have more mitochondria to make ATP to keep your muscles moving, and they have a higher blood supply to provide oxygen to break the glucose down in the mitochondria to make ATP. So your red muscle fibers are typically going to be your more endurance muscle. They'll be able to go for a longer period of time before they fatigue. The flip side to that is the white muscle, or light meat, dark meat. This would be the white meat in turkey or chicken breast. They have less myoglobin, fewer mitochondria, and a much less of a blood supply. They do not have as many blood vessels supplying blood to that tissue. And now you may be thinking, hey, this is 2, but we'll talk about in their speed of contraction. There's going to be a difference that will give us our 3rd different kind of muscle tissue. So let's think about a turkey, right? So the wild turkey, not a domestic turkey, they don't count. Domestic turkeys are bred from, of course, wild turkeys, but I'm talking about a wild turkey. In the course of the day, A wild turkey will spend its entire day on its feet. It will walk and run anywhere and everywhere it needs to go. As a matter of fact, if it can not fly through the course of that day, it will be a good day for that turkey. They can fly, but compared to other birds, they're just not as good at it. It takes a lot of energy to get a 20-pound bird off the ground and keep it going. So their wings are short for their body, but very broad. So their flight is a sprint. It is a short, explosive, fast, powerful activity that is not going to last very long. They'll fly from ridge to ridge, or they'll fly across a field if they feel threatened. Most of the time, though, they would just rather run out of trouble. The only time they're going to take to the air on a good day for a turkey is to fly up to their roost. They sleep in trees. They fly up into the tree to roost for the night, and then they fly down in the morning. That's it. If everything goes well for that bird, he won't have to fly at any other time during the day. So this is why you don't see flocks of turkeys migrating south for the winter. They're not. They just can't do it. They're not good flyers. So their breast meat, their flight muscles are white. They're fast, explosive sprint muscle they're not made for endurance. They fatigue easily. Their drumsticks, on the other hand, their leg meat is very dark. So it is an endurance muscle. It has high blood supply, a lot of myoglobin, a lot of mitochondria. It's darker in appearance, and they can run for a long time. As I said, they would rather just run out of trouble. So in birds, their muscle tissue is very specialized for those jobs. Now, if you look at a goose or a duck, their breast meat is dark because it is an endurance muscle. You do see these animals flying south for the winter. They will migrate and they will fly long distances, and you are going to need endurance muscles to do that. Now, we don't have that much compartmentalization when it comes to our different kinds of muscle tissue. We basically have all of these muscle tissues, white and dark, but it's in all of our muscles. And in some people, you will have a higher concentration of a different kind of muscle tissue than another kind of muscle tissue. And we'll talk about that as we go through this video lesson. So in people, these are the three kinds we have. We have slow oxidative fibers. They are small. They appear dark red. They are the least powerful type. They are very fatigue resistant. They are used for endurance. They are commonly referred to as slow twitch red. So small and good for endurance. So if you look at someone who is just naturally gifted as a marathon runner, they're going to have a high concentration of slow twitch red muscle fiber. The other kind is fast oxidative glycolytic fibers, or FOG. They are intermediate in size, meaning they're not as small as slow oxidative, but they're smaller than fast, the FG, the fast glycolytic fibers, as we're going to talk about here in a minute. They are intermediate in size. They appear dark red. They are moderately resistant to fatigue, used for walking. They are called fast twitch red, and they're kind of the best of both worlds. So we go to the other kind. This is going to be your quote unquote white meat or light meat. The fast glycolytic fibers or FG are large, white, powerful, suited for intense anaerobic activity of short duration. Sprinters muscles. Okay, so you look at a world-class sprinter or an NFL player. They're your wide receivers and your corners. They're going to be fast people. These are the guys that run sub 5.4, 4.5, 4.4, and now we even have guys that run 4.2 40s. That's 40 yards in 4.2 seconds. That's crazy. That's super fast. And your world-class Olympic sprinters. Usain Bolt runs the 100 meters, which is 110 yards, runs 100 meters in under 10 seconds. That's just crazy fast. Okay. They will have a high concentration of these fast twitch white fibers. So the three kinds that we're going to have are slow twitch red, fast twitch red, and fast twitch white. And we're going to find out that different people will have different concentrations of these muscle fibers in their bodies, and that will have a tendency to give them advantages in certain athletic competitions, as we will see. So here's a cross-section of a muscle, transverse section of three types of skeletal muscle fibers. So this is in one muscle, and we see all three fibers. So we look there, you can see the very darkest area is the slow oxidative fiber. That's your slow twitch red. The very lightest area of muscle fiber is your white muscle or fast twitch white, fast glycolytic fiber. And then the intermediate, your best of both worlds, are your fast oxidative glycolytic fiber. So here's how it breaks down. Slow twitch red, right? Slow in contraction, but they're very thin fibers, and they're really, really good at endurance. So your marathon runners, if you look at your long distance runners, they are lean, not very large people, not very thick people, long, lean, and, they'll run a marathon, 26 miles. It's crazy. If you look at the sprinters in the world, they are muscular. They're not huge, but they're built. They have a muscular physique, and that's because their muscle fibers are big. So they have that well-defined muscular look. And then you have the go-between. You have the fast oxidative or your fast twitch red. These are fast. They don't contract as fast as fast twitch white, but they're faster than slow twitch red. They're going to last longer endurance-wise than fast twitch white, but they're not going to last as long as slow twitch red. So if you want to equate this to modern sports, your 2 mile, your marathon runners are going to have a high concentration in their muscles. They'll have a higher concentration of slow twitch red. Your sprinters, the guys running the 100 meter or the 200 meter, they're going to have a higher concentration, or typically they will have a higher concentration of fast twitch white muscle. And then you have your decathletes, the guys who are good at everything. Not world class at one or two, but really good at everything. They probably have a high concentration of fast twitch red. You also look at the guys throwing the shot put, big, large, explosive. Be able to throw that large metallic sphere. I think in the Olympics I know in high school they throw a 16-pounder. I think. Or in college, a 16-pound ball. They throw it 40, 50, 60 feet. I'm not sure what they throw in the Olympics. It might be a 22-pounder. I don't know. I'll have to double check that. But anyway, it still has to be explosive. You still are fast. You have to really pop that thing off of your shoulder. but you have to be strong as well. And a lot of times you have to have a lot of endurance, depending on if you're a decathlete. You will have some long distance events, but you still need to be explosive. So if we look at that around the world, we can see that there are some people who are just natural born sprinters. There are others who are just really good long distance runners. And there are some who are stuck in the middle. Most skeletal muscles are a mixture of all three types of skeletal muscle fibers in human beings. About half of the fibers in a typical skeletal muscle are your slow twitch red or your slow oxidative fibers. Within a particular motor unit, all skeletal muscle fibers are the same type. So that means neuron A is only going to be controlling fast twitch red. And then neuron B is only going to be controlling slow twitch red. And then there'll be another neuron that will control in any given area your fast twitch white. You're not going to have neuron A controlling a section of fast twitch white and slow twitch red at the same time. It just doesn't work that way. For different motor units in a muscle are recruited in a specific order depending on the task being performed. So if you are sprinting, your body is going to call on your fast twitch muscles. If you are running a long distance event or doing something over a prolonged period of time, your body is going to call on its slow twitch red. Now, a lot of times you can look at where people come from, where they can trace their heritage back, and you can see that there are certain areas of the world who have people that come from that part of the world who are naturally better at these different kinds of events. There are people who are just faster than others. And a lot of times you can see that many times they come from a certain part of the world. And there are other people who are naturally good at just being big, large, strong, powerful human beings. And you can see that a lot of times they come from a particular part of the world. So, for example, if you watch the Olympics and you tune in and you see the 100-meter finals, these are the guys who have gone through their preliminaries and they are running for the medal. 8 to 10 individuals who are going to run for the gold medal and be deemed the fastest man in the world. I don't know if you've ever watched the Olympics or any track events when they get to the 100-meter finals, but I can tell you there are very few Caucasians in that event. That event is dominated by people with African descent. And there are some people who come from various parts of Africa, and they have a higher concentration of fast twitch white muscle fibers. And if you look at a football team is a good, your NFL teams, they're a good microcosm of what we're talking about. So your offensive linemen, big, slow, because they're, slower than your wide receivers. Number one, because they're all 300 pounds, but they're explosive. They're big, strong, and they're powerful. They are going to have a high concentration of fast twitch red muscle fibers. You'll see these guys if you ever watch the strongman competitions. So this individual that I have pictured here, his name is Hathor Bjornsson. He is 6'9", and he weighs, depending on where he is in his training, he is a 400-pound human being. Sometimes he's 415. There have been times where he has weighed, depending on where he was in his competitive cycle, he's been over 450 pounds. He is a large, massive human being. And if you ever get on YouTube and watch some of the stuff that he's done, especially in the Arnold Strongman competition, there's one video where I watched him one-arm dumbbell press a 270-pound dumbbell with one arm, pressed it over his head 4 times. He is a huge, huge human being. And for those of you who are fans of Game of Thrones, you've seen him on TV. He plays the Mountain on Game of Thrones, and he is enormous. Now, is he going to win a foot race? Not unless he's racing other ginormous human beings that hail from Eastern Europe, because that's where he comes from. So when you watch the strongman competition, you'll see a lot of individuals who come from Eastern Europe. Their names are going to end in ski and Noth and Skov, Sklanovic, those are their Kowalski. They're going to be big European white guys. And they're going to be your offensive linemen, and they're going to be your shot put throwers and your discus throwers and hammer throwers. They're going to be those big, strong, explosive, large muscle fibers that are fast and explosive, but very strong. Then you tune in and you watch the sprinters, and you're going to see a bunch of people who can trace their lineage back to the African continent. They're all going to be chiseled out of stone, no body fat, muscular, just lean, mean, physical specimens, and they're going to be as fast as all get out. They have a high concentration of fast twitch white muscles. And then you look at the guy over on the far right, this little Kenyan. This guy is lean, but if you look, his muscles are nowhere near as defined as Mr. Usain Bolt there, the world's fastest man. He also hails from Africa, but as you can see, he's pretty lean dude, and he has a high concentration. I would be willing to wager he has a very high concentration of slow twitch red. Now, this guy runs a marathon. I believe he did it in just right around 2 hours, which I think that was the record. I can't even think about walking a marathon, let alone running one in just a handful of hours. It just boggles my mind that he can do that. So don't quote me on that. It might have been 3 hours. I don't know. Whatever it is, it will never happen by this guy. I can tell you that. So it's interesting to look at people on this planet and see that depending on where you're from, you trace your family tree back, you may have a different concentration of these various types of muscle fibers in your body. All right, so let's move on. So the different kinds of muscle contractions that we're going to have, a twitch is a single fast muscle contraction in response to a single stimulus, which means one stimulus, one muscle contraction, done. And you can look at, there are different kinds of muscle contractions that are out there. Applying increased number of action potentials to a muscle fiber or a fascicle or muscle group results in fusion of contractions, which is called a tetanus, and the performance of useful work. So a twitch, a single twitch right here is going to be the one action potential and one muscle contraction. A wave summation is there is a action potential that causes a contraction, and before the muscle can recover, there's a second action potential, and boom, you get a more forceful muscle contraction because it builds upon that first muscle contraction. An unfused tetanus is a series of action potentials where you just have a number of wave summations causing a much more increased force of muscle contraction based on a number of stimuli or or action potentials. And then a fused tetanus is a rapid series of action potentials that cause one long, smooth, powerful muscle contraction. And those are your different kinds of muscle contractions: twitch, tetanus, and a wave summation. All right, and that is going to be enough for video lesson 4 for us today. All right, hopefully that gives you a better understanding of the different kinds of skeletal muscle that you can find in your body. And for those of you who are wanting to be world-class sprinters and you just can't seem to run faster than the other people, then maybe that will explain why that is. So if you have any questions, as always, just shoot me an email and I'll try to answer them to the best of my abilities. And don't forget to click like and subscribe. Hey, we'll talk at you later. Have a good one.